So hello and welcome to the Maths Guide, and today we're going to be looking at how to reverse a formula, and that brings us to the idea of an equation. So we already know how to put values into a formula if we know the formula. So let's say, for example, we wanted to find the area of a rectangle. We know that the formula for that is the length times the width, and then what we would do is we would put in the values that we have for length and width, let's say 40 by 20, and we will get our answer 800, for example. Okay, so that's working forward. What we want to do today is we want to be looking at how to find the reverse of a formula. And we do this when we're told what the answer is, we're told what the result of the formula is, where we are told what the output of a formula is, and we want to find one of our inputs. So normally you would say the area of a rectangle is equal to the length by the width. But when we know what the area is and what we're looking for is one of these, we usually put these on the left and this on the right. So you'll notice on the left I had area of a rectangle, and then underneath it all the way down I had equals length by width and all the values. That's because I was working out an expression. So I was working out an expression. Now, when we're told the result, the output of a formula, and we want to find one of the inputs, we're going to write them out this way. We write, let's say for example that we know that the width was equal to 20 centimeters, just say 20 for the moment, and the area was equal to 800, and we wanted to find out what the length is. Again, we'd write out our formula, length times width is equal to the area of a rectangle, of course. And this time we're writing it out with a left-hand side expression and a right-hand side expression. And this equals here tells us that the value of this is the same as the value of this. Now this seems a little bit too much information for what we're trying to do here, but I want you to get into the idea of if you're told the output of something, you can find out one of the missing inputs, and I want you to look at the idea of an equation. An equation is where any expression, when the value of any expression is the same as the value of any other expression. In this particular question, we know that the area of the rectangle is the same value as the length times the width. We're told what the area of the rectangle is. It's equal to 800. We're told what the width is, and we just know that L times 20 is equal to 800. The question then is, what is this missing value? And when we're working with equations, I want you to continually think of a few things that you can do. You're allowed to add things to both sides. You're allowed to subtract things from both sides. You're allowed to scale up both sides by multiplying by a number, or scale down both sides by dividing by a number. We don't really think of dividing, we usually think of just multiplying. Okay, so what we're going to do here, excuse me, you can divide is fine. What we're going to do here is we're going to divide both sides by 20. When we're working with equations, we want to think of working with one side and working with the other in a kind of a separate way. We know the answer to this. Let's have a look at writing it on the other side of the page. We know that something multiplied by 20 is equal to 800. We know how to figure out what that number is. However, when we're working with equations, I want you to get into the habit of thinking of adding, subtracting, multiplying, or dividing both sides by the same thing. This is the left-hand side, this is the right-hand side. I want you to think of it in this way. So I don't want something times 20 equals 800. I just want this something. How do I get that? Well, if I multiply by 20 and then divide by 20, I get back to where I'm started. If I divide this left-hand side by 20, I have to do the same to the right-hand side. So I divide the right-hand side by 20, and that works out. So something multiplied by 20 divided by 20 gets us back to our original something. 800 divided by 20 is equal to 40. And that's working with a square. This is what you would do in primary school. In secondary school, we use letters. So we're going to have L times 20 is equal to 800. And actually, well, we'll get to it later. We do the same thing. We divide both sides by 20. So L times 20 divided by 20 brings us back to where we started. You know this from primary school, multiplying by a fraction. So we end up with L is equal to 40. So this seems a very long-winded way of working out how to find out what the length is when we know that the width and the area of a rectangle is 20 and 800 respectively. But I want to give you the idea of what an equation is. It's when we have a value on the left-hand side is the same as a value on the right-hand side. For example, the length times the width gives us a value, and we know that that value is the area. So we know this value is equal to this value. When we're working with equations, we have a logical statement. We say this value is the same as this value. Therefore, if I divide by 20 on both sides, then this value will equal 40. So again, it seems a little bit complicated, the idea, but I want to get that little idea into your head. We're working for the reverse of a formula. And what we're working with then when we want to reverse a formula is an equation. Let's have a look at some simple equations. Some unknown number, let's call it x. X marks the spot. Plus 7 is equal to 30. I think straight away you can see that you know what this unknown number is, but let's use our rule of only being able to add, subtract, multiply, or divide both sides by the same value. Let's see what we get. Well, I don't want this value plus 7, so I'm just going to take away 7. I'm kind of undoing what I did here. And remember, if I take away 7 here, I have to take away 7 here. So x plus 7 minus 7, some unknown value, plus 7, take away 7, brings us back to where we started. Again, our equals are all in a line. We always tend to have this. 30 take away 7 is 23. And I say, if this statement here is true, therefore this statement is also true. It's a lot of English that we're using here at the moment, but I'm sure you have the idea. You understand how to work this out. All we're doing is we're undoing what has been done to our unknown value. Let's have a look at a trickier one. 3 times some unknown value is equal to 60. Not that tricky. I think you can realize immediately what the unknown value is, but let's follow our rule of being able to add, subtract, multiply, or divide the left-hand side and the right-hand side by the same value. So I don't want 3 times our value. We want to divide by 3. 3 times some value divided by 3, as you know with fractions, brings you back to where you started. If I divide one side by 3, I have to divide the other side by 3. So we know our unknown value is equal to 20. And we can see that 3 times 20 equals 60, as we expected at the start. Also, I say, if this statement is true, therefore this statement is also true. Let's have a look at a trickier question. 4 times some unknown value minus 16 is equal to, let's say, 48. Okay. This is going to take 2 steps. First of all, we've got 4 times some unknown value, take away 16 is equal to 48. We know that we would multiply this value by 4 and then take away 16. So to undo that, we're going to add 16. However, if I add 16 to the left, I have to add 16 to the right. What do we get? We're left with 4 times some value. Take away 16, add 16, brings us back to where we started. In a sense, these cancel each other out. You're adding 0. Equals underneath each other. So get in the habit of writing equals underneath each other, 1, 2, 3 in a row. That prevents you making mistakes. 48 plus 16 is 64. Therefore, 4 times x. We don't want 4 times x, so we divide by 4. If I divide the left-hand side by 4, I divide the right-hand side by 4. 4 times some unknown value divided by 4. As you know, multiplying by 4 and dividing by 4 kind of cancels each other out. You know this from primary school. That leaves us with our original unknown value, which is equal to 64 divided by 4, which is equal to 16. So our unknown value is 16. Let's check our answer. 16, 4 times 16 is 64. Take away 16 equals 48. That works perfectly. Okay, so I'm giving you a lot of information here. I realize this. We originally started with the idea of having a formula that we wanted to reverse. And then we brought it into the idea of having an equation. I want you to think of working with equations almost all the time. It's something that you get very good at, that you get very used to. So you may as well turn a question that you have into an equation and work with that. So we know that this value, the length times the width, is equal to this value, 800. These are the things that we can do. I don't want to multiply by 20, so if I divide by 20, the result is multiplying by 20 and dividing by 20, which brings us back to where we started. That's how you do that equation. If I have a plus 7, I want to minus 7 from both sides to bring this back to 0. I'm doing the opposite of what I've done here. If I add 7 and take away 7, that effectively does nothing. If I take away 7 from the left hand side, I take away 7 from the right hand side. Let's have a look at another question. Some unknown value divided by 10 minus 3 is equal to 1. Okay, so what order would I do this in? The unknown value would first be divided by 10, then I'd take away 3, and I'd get the value 1. I want to think of this as an equation with a left-hand side and a right-hand side. This is where my equals are going to be. So the last thing I did was I took away 3, so I want to undo taking away a 3. What's the opposite of taking away 3? It would be adding 3, which would bring us back to where we started. If I add 3 to the left-hand side, I have to add 3 to the right-hand side. So I end up with some unknown value divided by 10 is equal to 4. What's the opposite of dividing by 10? The answer is multiplying by 10. But if I multiply the left-hand side by 10, then I want to multiply the right-hand side by 10. Let's write this on another line so we don't get confused, so that it's clear what we've done from step to step. Okay, so I multiply the left-hand side by 10, I multiply the right-hand side by 10. If I divide by 10 and multiply by 10, we know that kind of cancels out. You know that from primary school. The result is our unknown value is equal to 40. Let's check our answer. 40 divided by 10 is 4. Take away 3 equals 1. So yes, that was true. We have the right answer. Okay, so we've had a look at what's the opposite of adding? It's subtracting. What's the opposite of subtracting? It's adding. What's the opposite of multiplying by 3? It's dividing by 3. What's the opposite of dividing by 10? It's multiplying by 10. Whatever I do to the left-hand side, I do exactly the same thing to the right-hand side. And to make sure that you don't get messy and confused, keep your equals in a row. Keep your left-hand side on the left-hand side, keep your right-hand side on the right-hand side. That's how you'll solve these. Okay, but in general, for formula questions, you're going to find them fairly straightforward. Write your answer, write the results, the output from your formula on the right hand side. It makes it a little bit easier for you.